there, welcome to Earth Science class. In this video, we will learn about the physical properties of minerals. Here is a rock. When you look at this rock closely, you can see pink color, black color, white color things. These are minerals. Pink colored mineral is K-feldspar, potassium-rich feldspar. Black colored mineral is hornblende, type of amphibole. White colored mineral is plagioclase. Potassium feldspar, hornblende, plagioclase are mineral names. This rock has many different colors of minerals. Rock is a mixture of minerals. What is the relationship between rock and minerals? Rock is a mixture of minerals. The name of this rock is granite. Now, what about minerals? What kind of things are in these minerals? Atoms are in the minerals. Minerals is atoms combinations, chemical compositions. They have a definite chemical composition. Minerals can be defined by a chemical formula. Please watch the other video for 5 criteria for minerals before this one. Minerals are composed of chemical atoms. The mineral halite has sodium atoms and chlorine atoms. Calcite has calcium, carbon, and oxygen atoms in it. Quartz has silicon and oxygen. Also, there is a complicated chemical formula for some minerals. Biotite has potassium, magnesium, iron, aluminum, silicon, oxygen, and hydrogen atoms. Hornblende has more atoms in it. Okay, look. Here is the mineral olivine, green color, orange colored mineral plagioclase. In the mineral, you see many chemical atoms in it. This is the rock peridotite. Peridotite is composed of lots of green colored mineral olivine and bits of black colored mineral hornblende. It is important to understand the relationship of rock, minerals, and atoms. Let's get back to the physical properties of minerals. Color, streak, luster, hardness, specific gravity, crystal habit, fracture or cleavage. All the physical properties of a mineral result from the mineral's internal arrangement of the atoms. Mineral color is the part of visible light that is not absorbed by a mineral. Diagnostic for some minerals, olivine is olive green. Some minerals exhibit a broad color range. For example, quartz has all variety of colors: clear, white, yellow, pink, purple, gray, etc. Color varieties often reflect trace impurities. Streak is the color of a powder produced by crushing a mineral. If you scrape the mineral hematite on the ceramic plate, there are some powder coming out of the hematite. The color of the hematite is dark gray, but the powder color, the streak, is reddish brown. Streak color is less variable than crystal color. Luster, the way a mineral surface scatters light. 2 subdivisions: metallic, looks like a metal; non-metallic, silky, vitreous, glassy, satiny, resinous, pearly, earthy, dull, adamantine, brilliant. Physical characteristics of minerals. Pyrite has a metallic luster because it gleams like metal. Feldspar has a non-metallic luster. Here are some mineral photos: galena, metallic; talc, pearly; muscovite, silky; graphite, greasy. When you take the minerals or rock photo, it is important to show the scales, such as a ruler here, giving exact size information. You can simply say metallic or non-metallic, or shiny or non-shiny. Hardness. Scratching resistance of a mineral. It is related with the strength of atomic bonding in the mineral. Hardness can be estimated to the Mohs scale for hardness of mineral. This is This is not absolute hardness, but the relative hardness. So for example, hardness number 1 is talc, and hardness number 2 is gypsum. This does not mean that gypsum is twice harder than talc. This is simply that gypsum is harder than talc. Let's look what they are. 1. Talc, graphite. 2. Gypsum. 3. Calcite. 4. Fluorite. 5. Apatite. 6. Orthoclase. 7. Quartz. 8. Topaz. 9. Corundum. 10. Diamond. The hardness of the fingernail is 2.5, so I can scratch talc, graphite, gypsum with my fingernail. Copper penny 3.5, glass steel 5.5, 6.5. The hardest, strongest mineral is diamond. If you have a diamond ring, you can scratch whatever with your ring. Please watch another video for mineral hardness. Specific gravity represents the density of a mineral. Mineral weight over the weight of an equal water volume. Specific gravity is heft, how heavy it feels. Galena heavy, specific gravity Sg 7.6, quartz light Sg 2.65. Galena feels heavier than quartz. So when you swim, you feel a bit lighter in the water compared to your weight on the ground because of the water buoyancy. Buoyancy is a tendency to float in water or air or some other fluid. Here is buoyancy effect. 10-gram object is measured as 9 gram in the water. As the object enters the water, some of the weight is compensated with the buoyancy of the water. Some objects float in water, while others sink. You would figure out that the objects that float in water are the ones that have densities less than the density of water, while the objects that sink are those that have densities greater than the density of water. This can be explained by the principle of buoyancy, which is very important in geology. Here is a cubic centimeter block of a material with a density of 0.5 gram per cc. If you place this block in a cylinder of water, the water level rises. That is, some water is displaced. According to the principle of buoyancy, the water that has been displaced has a mass equal to the total mass of the block. The total mass of the block is 0.5 gram because density is 0.5 gram per cc and volume is 1 cc, cubic centimeters, so mass is 0.5 gram. So 0.5 gram of water are displaced. Water has a density of 1 gram per cc, cubic centimeter, gram per cubic centimeter, and so we find that 0.5 cubic centimeter or 0.5 milliliter of water are displaced. So here is a volume of object 1 cc, and density of fluid is 1 gram per cc. So force of buoyancy is 1 gram, weight of object in air is 0.5 gram. So the weight of object in water is minus, which is impossible, but minus 0.5 gram. Now we can estimate specific gravity, weight of object in air divided by the weight of object in air minus weight of object in water. Here is the specific gravity. For this block is 0.5. The weight of an object water is 0 gram. Now we can estimate specific gravity, weight of object in air divided by the weight of the object in air minus weight of the object in water, here is the specific gravity as 1. Okay, this is another block density of 2.5 gram per cc. The weight of the object in air is 2.5 gram. The weight of the object in the water is 1.5 gram. Now, the specific gravity is 2.5. Okay. So here is the cubic object. Weight in air is 3.5 gram. So the weight of object in water is 2.5 gram. Now we can estimate specific gravity is 3.5. Now, the different case. Here is the heavy liquid, not water. The density of a heavy liquid is 2 gram per cubic centimeter. The force of buoyancy is 2 gram. Specific gravity again against the heavy water is 1.75 for this block on the heavy liquid, not water. Okay, physical property again. Crystal habit. A single crystal with well-formed faces or an aggregate of many well-formed crystals. Arrangement of faces reflects internal atomic structure. Records variation in directional growth rate, blocky or equal growth rate in 3 dimensions. Bladed, shaped like a knife blade. Needle-like, rapid growth in 1 dimension, slow in others. Special physical properties for calcite and magnetite. Physical characteristics of minerals. Calcite reacts with hydrochloric acid to produce carbon dioxide. 1 drop of dilute 10% hydrochloric acid on a piece of calcite. The chemical formula of calcite is CaCO3, calcium carbonate. CO2 gas comes out. If you make a nice sculpture with calcite, limestone, or marble, and if acid rain drops on the sculpture, the chemical reaction happens and carbon dioxide is out. This is chemical weathering. Another special physical properties is on the magnetite. Magnetite is magnetic and it attracts the iron nails. Here is a fracture. Minerals break in ways that reflect atomic bonding. Fracturing implies equal bond strength in all directions. For example, quartz displays conchoidal fracture, shaped like the inside of the clamshell, breaks along smooth curved surfaces, produces extremely sharp edges. Volcanic glass was used by native cultures to make tools. Fracture has irregular, uneven surface, conchoidal fracture. Cleavage. Cleavage is very important and a bit difficult to understand. Please bear with me. Cleavage is a tendency to break along planes of weaker atomic bonds. Cleavage produces flat, shiny surfaces, described by the number of planes and their angles, sometimes mistaken for crystal habit. Cleavage is through-going. It often forms parallel steps. Crystal faces only occur one external surfaces. 1, 2, 3, 4, and 6 cleavage planes are possible. How do you distinguish between cleavage plane and crystal faces? Cleavage planes can be repeated, whereas a crystal faces is a single surface. Cleavage is related to how to break. crystal phase is related to how to form. Example of cleavage: one direction, two directions at 90 degrees, two directions not at 90 degrees. The example of one direction of cleavage is that mica has one strong plane of cleavage and splits into sheets. The example of two directions at 90-degree cleavage is that pyroxene has two planes of cleavage that intersect at 90 degrees. The example of two directions not at 90 cleavage is that amphibole has two planes that intersect at 60 degrees. The example of three directions at 90 degrees cleavage is that halite has three mutually perpendicular planes of cleavage. The example of three directions not at 90 degrees cleavage is that calcite has three planes of cleavage, one of which is inclined. Cleavage and fracture are related to the atomic arrangement, crystal. They have a crystalline structure. Atoms and a mineral are arranged in a specific order. This atomic pattern is called crystalline lattice. Atoms in repeated order, crystal structure, if broken, cleavage, flat surfaces. Atoms in repeated order, no crystals, if broken, like fracture, uneven surfaces. Here are the photos of minerals for the lab. The minerals for galena, quartz, graphite, calcite, halite, biotite, and muscovite. Uneven surface, not flat surface, could be the fracture. The flat planes show cleavage. Here are some silicate minerals. Silicates are known as the rock-forming minerals. They dominate Earth's crust and mantle, made of oxygen and silicon with other atoms. The structure of silicate minerals. The fundamental building block of a silicate minerals is the silicon-oxygen tetrahedron. Oxygen occupies the corner of the tetrahedron and silicon lies at the center. Mineral olivine is the one of the silicate mineral with its silica tetrahedra. In the mineral olivine, there are atomic bonding with this silica tetrahedron. No specific weaker bonds. If broken, no specific direction to break, so there will be uneven surface, which is called as a fracture. Pyroxene has dark, long crystals, strong bonding inside. If broken, it breaks along the weaker ionic bonds like this, and we call it cleavage. Two cleavages near 90 degrees. Mineral amphibole has a dark, long double crystals. If broken, it breaks along the weaker ionic bonds like this, and we call it cleavage. So mineral potassium feldspar and plagioclase have this atomic bonding. Mineral mica group, dark colored mica is biotite. Silver colored mica is muscovite. They have two-dimensional flat sheets of linked tetrahedra, characterized by one direction of perfect cleavage. Potassium feldspar, plagioclase, this atomic bonding, no specific weaker bonds. If broken, the rectangular cut as a cleavage. The examples of cleavage direction geometries observed in the common rock-forming minerals. So basal, one direction of cleavage. Mica group and Turk are the examples. Rectangular cleavage, two directions of cleavage that intersect at 90-degree angles. Plateau class is an example. Prismatic cleavage, two directions of cleavage that do not intersect at 90-degree angles. Hornblende is an example. Cubic cleavage, three directions of cleavage that intersect at 90-degree angle. Halite and galena are the example. Rhombic cleavage, three directions of cleavage that do not intersect at 90 angle. Calcite is an example. Octahedral cleavage, four directions of cleavage. Fluorite. Dodecahedral cleavage, six directions of cleavage. Sapphirite is an example. Thank you very much.